Bismillahirrahmanirrahim. Conservation laws. So, we will talk about the conservation laws, and we discussed two Noether symmetries in the previous lecture. One is partial by partial t, and the other is partial by partial phi. So, we want to find out conservation laws corresponding to these symmetry generators or killing vectors or Noether symmetries. So let's start the conservation law. So generally the conservation law for a Lagrangian is this: partial L partial x dot I and eta I minus xi x dot I plus xi L minus a, where a is the gauge function. So this is for 4D space-time Lagrangian. 4D space-time Lagrangian. So we will use this formula to find the conservation law. Okay, eta and xi can be read from the generators, and Lagrangian will be given, and a is the gauge function. So let's do on the other slide. Okay, so let's find the conservation law corresponding to partial by partial t. Here eta naught is 1 and xi is 0 and a is also 0. So the general formula for the conservation is partial by partial I x dot I eta I minus x dot I xi plus xi L minus a. So this I is summed over. So if I write the full expression, so I will write the full expression. This is partial by partial t dot eta naught minus t dot xi, that is the first term, then plus partial by partial r dot eta 1 minus r dot xi plus partial by partial theta dot eta 2 minus theta dot xi plus partial by partial phi dot theta 3 minus phi dot xi, and there are plus xi and L and minus a. L in this case is the Lagrangian 1 by 2 f of r t dot square minus r dot over f of r dot square f of r minus r square theta dot square plus sine square theta phi dot square. This will be the Lagrangian for spherically symmetric black hole types Lagrangian. So if I use this in this equation, I have only this one term because other are 0. There are no eta 1, eta 2 and eta 3, and xi is 0 and a is 0. So I will calculate only this one term because other terms are 0. So in this case phi 1 is equal to differentiating with respect to time t dot, so I will get f of r t dot, and that is the conservation corresponding to that this generator. Similarly phi 2, which will be corresponding to in that case this will here this term will give me something and other are 0. That generator is x2 partial by partial phi. So here you see eta 3 is 1, eta 3 is 1 and other are 0, and xi is 0 and a is 0. So putting this in this expression, this is 0, this is 0, this is 0, this one give me something and other, this and this term is 0. So from that I will differentiate this Lagrangian with respect to phi dot. So I will get minus r square sine square theta phi dot. So this is the other second conservation law corresponding to this generator. This is the conservation law corresponding to this generator, and then this is the conservation law corresponding to x2. And you see this is called energy conservation, and this is angular momentum. So these are two conservation laws corresponding to these two generators, which are the Noether symmetry generator of this Lagrangian. In next video we will have to find the full set of Noether symmetries corresponding to this Lagrangian. So that will be next video on full set of Noether symmetries, and maybe I will define the full set of conservation laws hold in this type of Lagrangian. Okay, thank you.